Alright, geometry. Today we are going to work on our in class 43 on triangle proportionality, and that is part of your level 2 here. Okay, triangle proportionality theorem as well as the converse we're going to talk about today. Okay, so a combination of your level 2 and 3 coming at you today. Okay, so continuing our work on polygon similarity, we're specifically going to look at the triangle proportionality theorem here. Okay, so to review here, you're given triangle ASP. Okay, ASP is our big triangle here, is similar to triangle HSE. Okay, so to get our scale factor, which was mentioned at the end of the last lesson, okay, you take your small side of the triangle over the larger side of the triangle. Okay, so make note of that here. Scale factor is the small triangle side over the large triangle side. Okay, so in this case, the smaller triangles pick a side, and the two we know, we need two numbers that we know, right? I can't have this side and this side because there's a W there. I can't use this side and this side because there's a variable there. Okay, but I do know 20 over 56. Okay, and then that can reduce to 5 over 14. That's the scale factor. Okay, so we can use that to continue solving as we did earlier. Okay, so I can use that, and honestly, you guys can continue to write your similar statements. So AS, or your proportional, AS over HS is equal to SP over SE, and then AP over HE. Those are your proportions you'll use, right? So I can use that same scale factor as we actually did earlier, right? So 5 over 14 is equal to let's put them all in. So AS, that's our last one. So AS is X plus 18. And I have these backwards, so small over big. So let's rewrite that as HS over AS equal to SE. So we keep the small on top, which is how we wrote our proportion, right? Okay, so I just flipped these around. I just wrote them regardless of large or small, but since we're writing our scale factor with small over large, we want to keep the same thing on top that's on the bottom. Okay, so HS is X over AS, which is X plus 18, equal to SE over 5 plus W because that's SP. And then finally we have our HE over AP, which we reduce to 5/14. Okay, so you could now continue to solve for all of them. Okay, so let's start with 5 over 14 equal to 5 over 5 plus W. Distribute and cross multiply, so 5W plus 25 equals 70. Subtract your 25, so I've got 5W equal to 45, and I've got W equal to 9. Okay, using 5 over 14 equal to X over X plus 18. Okay, cross multiply, I get 14x equals 5x plus 90. So I'm going to subtract my 5x here. So it's 7x equal to 90. Sorry, 9x, not 7. I didn't subtract 7, I subtracted 5. So divide by 9 and I get 10. So I get x equals 10. Okay, and the last one, I have a y over here asking for the total length. So if w is 9, I know y is 5 plus 9, which is 14. So there are the three variables that we solve for. Little review, okay? I just switched, again, the proportions to make sure that the small stayed on top. All right, next. Let's use the answers from above to test each of the following proportions to identify whether they are true or false. So is SE over SP actually equal to HE over AP? So let's put in here what we've got. So X we found to be 10. Y was 14. So SE is 5 over SP, we got to be 14, equal to HE, so 20 over AP, which is 56. So again, reduce that, and I get 5 over 14, so that's true. So then I need to check his SH, which was 10, over HA is 18, and I'm checking to see if that's equal to HE. Over AP. I think this is supposed to be SA. Okay, so if I reduce those, I get 5/9. 18, we're going to change to 28. So I get 5/14 equal to reduced. I had 5/14, which is again a true statement. Okay. If we were actually looking at SH over HA and HE over AP, then it would be false, right? Because it would be SH is 10, HA is 18, HE is 20, and AP is 56. So reduced, that would be 5/9 and 5/14. Okay, then that would be false. Okay. And the last one we're looking at SE. I do think we want to actually look at this one. So that's going to be false because we're leading into something else here. Okay. So SE over EP. SE, as we see, is 5 over EP is 9 equal to SH, which is 10, over HA, which is 18. So again, if I reduce that, I get 5/9. So that one's true. Okay, sorry, we're leading into something else. I was thinking we were kind of trying to prove. So I thought there was an error there, but it was actually supposed to be HA. Okay, so true, false, and true. So using one of the descriptions below, fill in the proportions used in each part of number 1 with their corresponding labels. The first one has been done as an example. Okay, so your description choices are to either use small triangle side, large triangle side, or neither. Okay, so on the first one, as it said, it was done for you. So SE, up in your triangle up above, is the side of the small triangle. SP is the large triangle. And we're checking to see if it's equal to HE, which is from the small triangle, over AP, which is from the large triangle. Okay, so this is helping you identify the small and the large. Okay, so SH is the small triangle side, over HA, which is neither. Right, it's only part of the large triangle, it's not the whole side. HE is from the small triangle. Okay, and AP is from the large triangle side. And then on the last one, SE is from the small triangle side. Okay, it can't be part of the side, it has to be the whole side. EP is neither, it's only a part of the large triangle, right? SH is from the small triangle side. And HA, again, is neither. Okay, so when we look at this, what occurred that caused the false proportions? Okay, well, we had mismatched, right? Mismatched parts in our proportion. Okay, did any of the true statements surprise you? So up here, so number 2, all A, B, and C were the same as the A, B, and C here. Okay. These A, B, and C's down here were the same as these. So the question is, did any of these true statements that A or C were true surprise you that here we had a small size equal to small side over a large side equal to large side? But this one kind of surprised me, that we had a small side over a neither equal to a small side over a neither, right? So what we could say here for our what surprised us is C maybe surprised us because the proportion doesn't match. What we learned, right? We learned that for proportions, it's small side over large side equals small side over large side. So it really doesn't match what we've learned so far. Okay. Next page, we get to the triangle proportionality theorem, which is what that was leading up to, which I remembered partway through that second one that I thought was a typo. Okay, so what the triangle proportionality theorem says that if a line is parallel to one side of a triangle, okay, then the parallel divides the other sides of the triangle proportionally. Okay, so for example, what that means is if my parallel line here, parallel to the bottom, the F segment, okay, divides them proportionally. So what that means is, for example, B over A, side B over A, even though it's not a triangle, it divides them proportionally. So that would be equal to D over C. Sorry, that's an A here. That line got a little long. Let's make it look like an A. Okay, but you cannot use this theorem to find the bases, we'll say, to find E or F. Okay, cannot use the bases to find E or F. Okay, we can, if we know that they're similar triangles, we can, okay? But not with the parallel line through the triangle. Alright, so to find the value of x in our first one, okay, we can say, we've got parallel lines here, so we can say 40 over 70, or 4/7, I'm going to use smaller, right, reduced is all, is equal to 52 over x. Okay, if you don't reduce, that's fine. Since you get calculators, it's not as big a deal. So I get 4x equal to 364. When I divide by 4, I get x equal to 91. All there is to it. Okay, next one. Okay, if you need to turn it so you're looking at the triangle like that, do it. Okay, then I can say 3 over x 4 over x plus 3. Let's multiply and solve. So 4x equals 3x plus 9. Make sure you distribute that 3 to below. So I'll subtract 3x to solve here, and I get x equals 9. And that's all I'm asked to find was x in this one. Okay. Next one, find x and y. So I'm going to first say 9 over x plus 3 is equal to 4 over x minus 2. Okay. So I get 9x is equal to 4x, oops, sorry, that's 9x minus 18 is equal to 4x plus 12. So subtract your 4x, but add 18, and you get 5x equals 30. Okay, so x equals 6. Okay, so if x is 6, I can plug that in here. And I get that this total length, 6 plus 3 is 9, so that total length is 18. Okay, so now I can set up a proportion using, if I have similar triangles. So I have 9 over 18, small side over the long side, is equal to the small side over the long side. So 9y equals 18 times 7 is 156, I believe. I'm going to double check that. It is 126, so divide by 9, and I get y equals 14, and x equals to 6. Okay, so the converse of the triangle proportional theorem says that if two sides are a triangle, two sides of a triangle are divided proportionally, then the line that divides them is parallel. Okay, so it's saying if a line, if two sides of a triangle are divided proportionally, so we can check to see if they're proportional, then we can say that these are parallel. Okay, so we can check using our triangle proportionality theorem is 5 over 15 equal to 7 over 20. If I reduce, I get 1 over 3. This doesn't reduce, so my answer is no. The question was, are A, B, and C, D parallel? Okay, the answer is no because they're not proportional. Okay, so here we're going to check our proportions, and we're checking to see if AB is parallel to CD. So we're going to say 6 over 9 is equal to 12 over 18, and that's what we're checking to see. Put a little question mark there. Okay, if I reduce that, I get 2/3 equal to divide by 6, 2/3. So my answer is yes, AB is parallel to CD. Here I probably should say no, AB is not parallel to CD. Just put a slash through the parallel line. Okay, and that, my friends, finishes off our triangle proportionality theorem, and you should now be able to go ahead and complete your homework.